So the third workshop of the day will be Introduction to NLP. So it's the natural language processing, which is concerned with understanding, interpreting, and manipulating human language. So through this introductory workshop on NLP, you will get the chance to explore the applications, syntactic and semantic analysis, challenges, and techniques. And we will take you through techniques like parsing, text segmentation, named entity recognition, relationship extraction, and sentiment analysis. Ooh, that's a mouthful. All right, so today we're lucky enough to have Elham, which I'll let Tim introduce.
Yeah, thank you, Monica. So we're very lucky to have Dr. Elham Karadman. So we've been fortunate to have her on the team for, I think it's more than a year now, just around a year, I guess. And she leads the AI team at AI Launch Lab. And she is an R&D scientist at Actionable. She's a postdoctoral researcher at University of Montreal. She's a PhD in mathematics, specializing in algorithm development, machine learning, and optimization. So thank you so much, Elham.
Thank you so much, Dimitri and Monica. So I will start first with sharing my screen. Just one moment. Perfect. Not the first page. So everyone can see. Perfect. So today I will explain a little bit about NLP, but that is only the introduction. And next week I will explain more about more techniques in NLP, or I will show you more that how you can code and what kind of libraries that you can use for NLP. So I will start first with what is NLP and what is natural language processing. You can see the second slide, yes? Okay, perfect. It is a subfield of computer science and artificial intelligence, which is concerned with the interaction between computers and human and natural language. So the ultimate goal of NLP is to help computers understand language as we build it. And NLP is all about making computers understand and generate human language. It is used to apply machine learning algorithms to text and speech. So there are two applications for NLP that you can see that they can understand text. For example, if there are some written text, trying to understand the concept, trying to understand many kind of features inside the text. And the other one is speech, that understand when someone is talking. So here you can see three division of this field. Can be speech recognition. That means that they can translate a spoken language into text. And the other thing is natural language understanding. So it's the ability to understand what we say and what we write. And the other one is natural language generation, the generation of language, natural language by a computer. So the application of NLP, I think you all have the experience of the NLP. If you have, for example, Siri, Cortana, or Google Assistant, when you can talk with them. And the other thing is autocomplete. When you're searching in Google, you see that they're predicting or suggesting some words for you. And spell checking is another application of NLP that can be used in Microsoft or other kind of application, and Google Translate. But there are, besides this, these are not limited to this application. We have kind of different application of NLP as well. Why natural language NLP is difficult problem? What are the challenges that you can see when you use natural language processing and you want to understand the language? The first thing, that natural language, human language, is still difficult for human to understand. And that comes exactly from that challenges that we have when we talk. Sometimes we don't understand each other. When we write, sometimes when we read, we cannot understand exactly what's the meaning or what's the content of that writing. So you see that all the text is kind of discrete symbols. There are some categorical signaling system. That means that they convey meaning in different ways. You can see at the right side, I put it one sentence, but there are different meaning of that sentence. For example, are you going to eat that? So you see that, you know, it's like, it's very hard to understand, like when you just see the sentence and understand the meaning, because it's possible to have different meaning. Another challenge, for example, when you talk and you want to use the word like to is like, can be written in different ways, can be applied in different sentences, but can have different meanings. And this is that's something that when, for example, you're talking with Cortana or Google Assistant, they say that, sorry, I don't understand what you mean. So that's the challenge, that is still is hard to understand some text or speech. The other challenge, that we have multiple meaning words. For example, fall, net, for example, apple. Apple can be apple that you eat, or apple as a brand of computer. That is kind of challenges, but I will tell you that what kind of challenges we can handle using NLP, but something that we cannot. The first thing that we use in NLP, we want to understand that what kind of techniques, or what kind of things that we can get from a natural language. There are two things that is like primary techniques that lead us to understand the natural language: syntactic analysis or semantic analysis. Syntactic is the grammatical structure of the text. Semantics is the meaning being conveyed. So syntactic analysis is referred to as a syntax analysis or parsing. It's the process of analyzing natural language with the rules of a formal grammar. A semantic analysis is the process of understanding the meaning and interpretation of words, sign, and sentence structure. These are, I will introduce you here that what kind of techniques we can use to understand text. The first thing here is tokenization. So you should remember these kind of techniques. Tokenization is meaning that we want to split the text into some tokens, so list of tokens. So these tokens can be a paragraph, can be a sentence, it can be like you token a sentence that you can see here to some words. But there are different ways. You see that one sentence, there are different ways that you can token and then separate each word of, or each sign of one sentence. The other technique is removing some words that is very common and doesn't have any meaning in the sentence. And we call it stop words. Stop words are the most common words in the language. For example, of, for, at, de. This is something that doesn't have many meaning. So, and sometimes it's suggested to remove these words. And what's the benefit that we can get like removing these stop words? It's just because the data set that you have is like a big data set. You can have like a sentence with many words, and this removing stop words can give you the opportunity to decrease the time to train the model, and also potentially help improve the performance, that there are fewer and only meaningful tokens left. So at the end, it increases classification accuracy. Other thing is parsing. Parsing meaning that, okay, what kind of nouns I have here? So when you parse a sentence, you can parse it to different kind of entity, and then over there you can understand it better. The other thing that we use most of the time in NLP is stemming and lemmatization. Stemming is a technique that comes from morphology and information retrieval, which is used in NLP for pre-processing and efficiency purpose. So it's defined by the dictionary as originate in or because by. For example, using stemming, I have the word changing, change, and change, and then I cut all the red one to just keeping change, and then when I have like changing and change, that computers only see all of them as one kind of word. Lemmatization is exactly the same, but the difference of stemming and lemmatization is stemming, you just cut the something that is extra. For example, developed, we only remove ed, but lemmatization, we have a source as call it word net, and over there it's matched before. For example, drive, drives, drove, driven, all of them are matched to a one word which has a meaning. So you see, drive, we have an e at the end, but if I want to use stemming, I did an e at the end, and then I have drive. So maybe if you can see some stemming words at the end, you cannot see like the exact word, but using lemmatization, you can see the exact word. Here I put another example, and you see that like the word, if it's is or am, I want to stem that. So I change to is and am, but lemmatized, so change it to be. So this is difference between that, but it's up to you that you want to use stemming or lemmatization, but usually lemmatization is recommended. The other thing is text segmentation. We want to separate like different words, entity inside the sentence to understand the meaning or understand the semantic of the sentence. For example, one thing that is most of the time used is called named entity recognition, or NER. NER is you have some sentence, you can, for example, define that I want to only detect the name of organization inside a text. I want to know and understand where is the name of the person. I want to know if there is a date inside, and I want to extract only date. So you see here that there are different type of entity that you can define, and then starting to detect those entities inside the sentences. So the last topic is sentiment analysis. Sentiment analysis is usually used and is actually really cool because you can understand the sentiment of a sentence. Is it positive? Is it negative? Or is it neutral? And mostly it is used when you want to classify some reviews, or you want to know that if there is a positive tweet about a subject, or if this is a negative tweet about a subject, and those negativity and positivity can help you to understand or make a decision based on that. And for example, if you want to understand what are kind of reviews related to food of a restaurant, so you can categorize, okay, how many of those reviews were positive or they were negative, or sometimes it's mutual. And the last one here, that is topic modeling. Topic modeling is also very useful because, for example, you have a text, but there are different topics inside the text. They can talk about physics, they can talk about geography. So, but topic modeling usually is unsupervised machine learning techniques that are capable of scanning a set of documents, detecting word, phrases, pattern, and then based on that, you can automatically use by using clustering, you can automatically group them and then define, okay, I found 2 or 3 different topics, and based off the frequency of the words, I can understand what are those topics. So now here I share with you some, maybe I can take some, are these techniques also represent when doing NLP for language that don't stem from Latin? Actually, this natural language processing is used for any language. It's not limited to English. It can be used to any language, and also the connection between two languages when we want to translate. And also, yeah, if you don't stem, for example, from Latin, if you don't stem it, actually you can also use that, but like using stemming can help you to decrease the dimensionality of your data, and that helps us like to increase the accuracy and performance. So I share with you a collab, Google Colab, and then now I share my screen again. And then here I introduce you a very useful and library in natural language processing, which is called NLTK. You can easily, like the first one, you can easily start like install it, and then you can start doing some tasks. So first we download NLTK, everything. And here I put for you this text. So this is the text you see, natural language processing is a field of linguistics. And there's a dot here. And the second task, I want to split it into sentences. So it's very easy that I use sent tokenize. So, and then I put that text. And then easily here that I have the list of sentences. You see it, I have like the first sentence, you can detect from the other sentences. I can also use word tokenize, and I use that over that text, and I tokenize it, list of words. And if there is a symbol like parenthesis, it's also understood from that as a different sign. We can use NLTK to find synonyms and antonyms. And for example, here I want to show you how you can use synonyms. So synonyms, I want to know that what is the synonym for AI. So the first one is like artificial intelligence, army intelligence, and then other things. But I want to know that, okay, for the second one, which is artificial intelligence, give me a definition. So the branch of computer science. And that's the definition. And then it said that, okay, give me an example. So I put this in number 1, which is this one, and then give me an example. Workers in AI hope to mitigate. So this is an example using that word. We can also use antonyms. So antonym, for example, ugly. I want to know what is the antonyms of ugly. So here, there's a code that you can easily find it, and then it's beautiful. In NLTK, you first download the Star Wars, and the Star Wars here, I put the Star Wars that set Star Wars for English. You see, these are the Star Wars in English: is, those, your, do, against. These are the very, very common words that maybe there's no meaning inside. And then I use a Star word in English, and then I want to remove, for example, some of them. And here, I first filter the text for Star Wars. So here I filter some of them, and then here I have with Star Wars, so I tokenize. So Star Wars is always before. Star Wars is also removing after tokenization. So you have to do tokenization, and then you can remove those Star Wars. And then I can remove, you see that here there's no is, there's no a, that there's no of. Stemming was another task that in NLTK you can easily use this kind of techniques or this kind of command. Here you're using NLTK, and then use that to use stemming. I put here some example, and then I use that for like stemming those words. We can use stemming for a sentence. And here you see code is newly founded, but you see that newly is changed to new LI. And then founded is changed to found private university, but university is universe. So lemmatizing, so this is the same, but like exactly the same, but different kind of commands that you can use from NLTK to use to have lemmatizing. So I go very fast because you have this code and you can easily try it for yourself. But after this workshop, if you have any question, you can ask me. Parsing is another task that is also we can use NLTK to do parsing. And here you see like a one sentence here that we parsed it. For example, we have de, it's like DT, we have ball is noun, and which is CC. You know, like every word we can categorize it that what is this word. Chunking text and is the last one that you see like there's one text and then over there we can find the relationship between these kind of words, and that's the task you can do like later as an assignment. But not an assignment, like practicing, you can practice more with this Google Colab, and then you can ask questions later. So I'm happy to take some questions. Okay, is there a Python script that I can translate a mathematical paper written in German? Oh, the mathematical, I don't know exactly about that, but a mathematical paper, so mathematics, there's no need that you can translate. But NLP is not about the formula, NLP is about the text. But if the text inside that paper is written in Germany, is written in German, so you can easily translate that into English. But about like the mathematics formula is not related to NLP. Do you have any site web in mind if we want to learn more about NLP? I don't know any specific, but Monkey Learns, you can find some good NLP explanation. But for me, if I want to learn something, I just Google it, and then after that, I can go through like the result and then understand more about that topic. But this is not limited to this workshop. Next week, we will have other workshops, and then we will work on the other kind of techniques in NLP. The other language except English, are there libraries for those languages to use for NLP? Yes. Most of the libraries that is useful for English, they can use that exactly the same libraries and especially NLTK can also use for English. You saw that for stop words. I put what is the language and I put English, but you can change it to another and even to another language, but even some high level techniques in NLP is written and is developed for different languages. Okay, I think there's no question. Which library is good for NLP? Both of them are good. SpaCy is really good for name entity recognition, but it depends on what kind of task you want to do, but both of them, and NLTK is also good for it, but the result is different. But I cannot say that which one is better than the other. Both of them are very helpful in NLP.
All right. Well, thank you so much, Elham, for that. Really appreciate the care and time you put into that. It was amazing.